Okay, so today we are going to be talking about linear inequalities, and this is just a review. So if you have never done linear inequalities, maybe you need to review before this because it's going to go pretty fast. Because after this lesson, I want you guys to be able to graph a linear inequality and understand that the graph of a linear inequality represents all of the solutions that are to the inequality, which means everything that could balance the equation or balance the inequality in this case. So basically make it true. So I guess it's not really balanced, but it's making it true. Okay, so let's talk about what does it mean to make the inequality true? Let's see if I'm even going to be able to talk today. Okay, so this example says, is 3 - 4 a solution to this inequality? Okay, so pause the video and decide what you think. All right, well, if you said yes or if you said no, I'm hoping that you have something down there on your paper to stand behind your answer. But let's see what we are going to do. So every point is an x and a y value that are said to work together. So if this is an x and y value that is a solution to this inequality, then that means that it makes the inequality true. So if I put a -4 in for y and I put a 3 in for x, the inequality should be true. So the question is -4 less than 6 minus 3? Now 6 minus 3 is just 3. So is -4 less than 3? And the answer is yes. Yes, this is true, which means yes, it is a solution. Okay, cool. Well, if we don't have the graph of it, we're just substituting things in, right? But actually, what's kind of cool about having the graph is we are going to look at a half plane that is true. Because when we just look at a line like y equals 2x minus 3, this is a boundary, right? So what that boundary does is it cuts a plane in half. It says that either I'm going to take all of the y values below this, or I'm going to take all of the y values above this. Now, if we're looking at the inequality below, the graph of the inequality below, you guys can see if we were looking at this, this would have a y-intercept of 3, and it has a slope of up 1 over 1, up 1 over 1. So this is 1x plus 3. Now, the question is, are we taking the y's above or below it? So if I'm looking at this x value, this is the x value and y value on the point. If I was taking the y values below it, these points would be shaded. But if I was taking the y values above it, or greater than the y value I got, these guys would be shaded. Well, you can obviously see that the ones below are shaded, and that's why we're going to have this symbol. Now, the dotted symbol, we know that if we're going to use this or this is going to be a dotted line, and you have this or with a line or this with a line, it's going to be solid, right? Dotted, solid. Solid means we are including that line, right? So this is everything below the line. Well, if we're looking at a graph and we're asked if these are solutions, if we look at 5, 0, 5, 0 is right here. And yes, that's in the shaded region. So yes, this is a solution. Now, if we had the inequality, again, we could have put the 5 in and a 0 and found that 0 is less than 8, right? But we don't have to when we have the graph, and that's kind of the beauty of this graph. It represents all of the points that would be in the solution set. So now we're going to go to -1, -1, 2. Now -1, 2 is actually, and let me erase this part, is actually right on the boundary. Now remember, we said when we have the dotted boundary, it's not included. And when we have the solid boundary, it's included. So this is on the dotted boundary, so this is not included in the solution. Now, if we went to our inequality and plugged our -1 and our 2 in, we would have 2 is less than -1 plus 3. Well, 2 is not less than 2. Do you see? We would have needed that equal sign in order to have that be true. So in this case, we have the dotted line, so this is not true or not a solution. Okay, let's look at another one. We have -4, 4. So we're going to go to -4, 1, 2, 3, 4. Well, that's not even in the shaded region. So we know this is not a solution. Yes, it's a solution. No, it's not. And actually, we should just say no, okay? All right, now we're going to look at 12.3. And oh my gosh, it's off our graph. It is off our graph, but you can see that it's basically right here somewhere, right? Well, that means that it's in our shaded plane, the shaded part of our plane. But again, if we don't have the picture, we can kind of decide if it's in that area, or we can just put it right into our inequality, which is 3 is less than 12 plus 3, and so 3 is less than 15. Yes, it's part of our solution. Do we have to have the inequality to find out if it's in that plane? No, not really. Okay, but it could help. All right, let's move on. So as we just talked about, if we have the line on the bottom, it's going to have an equal sign, so that means it's going to be a solid line, and that boundary, that line, is going to be included. In this case, it's a linear inequality, so the boundary is a line. If it is dashed line, that means the boundary is not included in our solution, okay? So our boundary, in this case, because it's a linear inequality, is a line. And in example 2, it was dashed, which meant that its solution was not, or its boundary points were not included in the solution. Okay, so if we don't have the graph, how would we choose which half plane should be shaded? There's lots of ways that people can tell you to do this, and some people are just going to say if it's less than, you go below, if it's greater than, you go above, and that's a great idea. Just like we talked about above, if it's less than, it's going to be smaller, and if it's more than, it's going to be higher, right? But here's the deal. You have to have y alone in order to do that, because you are talking about the y values, right? So if you don't have y alone, this might not be fantastic for you. So, okay. So how do we choose? How do we find out which half plane we should shade? Well, we can choose any point. Choose any point that's not on the line, because obviously if it's on the line, we know that it's either included or not included, right? And then we substitute that into the inequality, and if it's true, we know that we're including it in the solution. If it's false, we know that that's not the one we're including in the solution, the other part is. So here's an example, example 3, and you guys can go ahead and try these examples one at a time, and then push pause, and then see how you did. So when we're looking at this example, this is just y equals mx plus b. This is the boundary. It's linear. So we can graph this. We start at -4, and we use our slope up 2 over 1, up 2 over 1. And we know that because there's an equal sign in this, that we are going to use a solid line. Because of that equal sign, we are going to use a solid line. Okay, cool. Now you can see the half planes. So let me talk to you about what I mean by half plane. You have this half, or you have this half. One of those halves is going to be true. So if I pick a point in the yellow and it's not true, then the blue was true. If I pick a point that was in the yellow and it was true, then we know that the blue was not true. All those points are not true. Now, if we just talked about the y values and I just picked, let's say this y value right here, if my y values are higher, they're going to be in the yellow, and if my y values are lower, they're going to be in the blue. So that's one way to look at it if you want a shortcut for the ones where y is alone. And please be careful, because this is only going to happen when y is alone. So let's do it the old-fashioned way. Let's just pick any point. Now, here's the deal. 0, 0 is the easiest point. And if 0, 0 is not on your boundary, pick that one. So if I have 0, 0 and I substitute it into my inequality, 2 times 0 minus 4, I'm going to get that 0 is greater than 0 minus 4. So 0 is greater than negative 4. Guess what, guys? This is true. It's true, and my point is in the yellow region, which means the yellow shaded region is the solution region. So we will keep that yellow shaded region, and I obviously didn't shade perfectly, but it goes right up to the boundary and off to infinity. Okay, so let's look at the next one. Here's an example of a graph where y is not alone, right? So if I was looking at this would be like standard form. Now, could you put y alone? Yes, you could, okay? But when you have an inequality, you do have to remember that when you have an inequality, if you multiply or divide by a negative, you are going to have to change the inequality, okay? So I caution you to doing that because number one, it's more work, and number two, there's more room for error. When we have anything in standard form, we look for the x and y intercepts. Well, when I'm talking about the x-intercept, it's like not having the y, okay? So when the y is 0, this will go away, and x will be 6. So 1 point will be 6, 0, okay? And we will look at, so that's the x-intercept. That's when you make y 0. When we want the y-intercept, we will make x 0. So when is negative 2y going to equal 6? That is when y is equal to negative 3. Now, some of you might be wondering, oh my gosh, where'd you get the equal sign? I'm just talking about the boundary right now, guys. So don't worry about that inequality until we're shading, okay? So this is going to be at 0, because we zeroed that out, negative 3. So now we have the x and y intercept, and we have the ability to draw our up 3 over 6. Our line. Sorry, I didn't mean to go. Now, our line in this case is going to be dashed because there's no equal sign. Okay, that's roughly where we are, and you can go all the way over. Okay, so, all right, so this is our boundary, and again, we have two things. We have the yellow side, the yellow half plane, and we have the blue half plane. Now, we have to pick a point. Now, can you guys remember what point I told you to pick? Yeah, 0, 0. If 0, 0 is not on our boundary, we're going to be able to pick that, right? Because we already know what's happening on our boundary. We just need to know what's happening in our shaded regions, right? So if we pick 0, 0, now we're in the yellow region again. We put a 0 in for x and a 0 in for y, and we see what happens. This means that 0 is greater than 6. Excuse me, no, it's not. Not true, right? Not true. Well, if it's not true in the yellow, then it must be true in the blue, and that's where we're going to shade, and we're going to keep that region. All these are solutions. Now, do you have to go try another point in that region? No, you don't, because it's either true or false. And so if one is true, the other one is going to be, one is false, the other one's true, etc. Whoa, okay, so this is another one example of when y is not alone. This is point slope form. So when you have point slope form, you're going to want to graph your boundary using a point, obviously, and the slope. So our point is going to be what x value would make this 0, and we get a negative 4. And what y value would make this 0, and that would be a 3. Now, if you think about it, point slope form is y and then the opposite of the y from our point. And then you have your slope, and then you have x, and then you have the opposite of your x from your point. And that's why we're doing the opposite of what's in there, okay? So we're at negative 4 3, 1, 2, 3. If you needed a review on point slope form, just let me know and I will review that with you. Okay, so our slope comes from in front of the parentheses, so that's going to be -1/2. So this is going to be going down 1 over 2, down 1 over 2, down 1 over 2, etc., etc. And we could have gone up 1, back 2 if we need more points. Now, there's an equal sign here, so that means we're going to make our boundary solid. Whoa. Hopefully you guys are better at drawing these lines than me. Okay, so we have our half plane, and we can keep going so that we can have a better half plane, but all right. So we have our half plane. Again, it's breaking it into two things. It's breaking it into a blue section, and I'm just randomly picking one for blue and one for yellow, and a yellow section. Now, I told you 0, 0, but we have to make sure 0, 0 is not on our boundary. If it is, we just pick any other point. 0, 0 is not on our purple line, so we can use it and we can substitute it in to our inequality. So this is -3 is greater than or equal to -1/2 times 4. And so this would be -2. Is -3 greater than -2? No, this is not true. This is not true because more debt is not better than less debt, right? So if yellow is not true, you guessed it, we're keeping the blue. And that will be where all of our solutions lie in this half plane. And you have to actually, All right, I hope this helped you guys, and take care.